Hello, I'm Bob Kummerfeld, and this is the third video in a series on representing data inside the computer. This video covers characters.
Now, obviously, we can store characters using some sort of patterns of bits, and this is often the case where they represent the character in a single byte. Now, we know that bytes are 8 bits long, so if we had an 8-bit number, how many characters can we represent in that single 8-bit field? Think about it for a moment. How many different numbers can we represent in an 8-bit field? Well, it's all zeros to all ones as binary, which is 0 to 255. So that means that we can represent a total of 256 characters in an 8-bit number or in a single byte. You can also represent characters as multiple bytes, either a fixed number of bytes, such as 2 or 4 or whatever, or you might represent the characters in multiple bytes. So you might have a bit pattern which can span 1, 2, 3, 4, or however many bytes you need. Of course, then you need some way of indicating how many bytes are involved in the character. So let's have a look at an example. We can represent characters using a code that associates a 7-bit number with a character. And this is a particular code I'm showing you here. It's called the ASCII character code. And the first letter here I've got is A, and its representation is 1, and then 0000001. Which is 65 in decimal, B is 66 in decimal, and so on. That's all the capital letters, and small a, lowercase a, begins at 11000001, and so on. And of course all the special characters are also represented. So if we see a bit pattern in a byte that looks like 1 and 6 zeros, then that's a particular character. If it's 1 and 5 zeros 1, that's the letter capital A, and so on. Now, in this case, it's a 7-bit code. So the largest character value that can be that's represented is all ones, and you have a range of values from 0 to 127. So here the implication is that we can only represent a total of 128 different characters because there's only 128 different bit patterns. Now ASCII, this word ASCII, is actually an acronym. It stands for the American Standard Code for Information Interchange and is quite an old standard that was developed way back in the 1960s for representing characters inside computers. Now, because you can only represent in ASCII and in a single byte, in 7 bits, you can only represent 128 characters. That's fine for languages like English, but what about other languages that have other glyphs, other symbols, not just the Latin symbols of A to Z? And numbers and so on. Even languages like French and German and so on that have extra annotations on the characters. But then you get to a language like Chinese that has a very, very large number of characters in use in the language. So in order to represent these character sets, you'd have to have a much bigger range of values that you can use to represent the characters. So there were many proposed standards for how we should do that, but after a number of proposals, a character code called Unicode was developed by a consortium of companies and universities, and in cooperation with the International Organization for Standardization, and it was first released in 1991. It's gone through many revisions since 1991. I think they're up to about version 14 now. And with each revision, they add more characters to the code. And so they can now represent a very large number of characters. Now Unicode uses 4 bytes, 32 bits per character. And we know that 4 bytes can represent a number up to in the region of 4 billion. So you could represent over 4 billion characters in your 4 bytes. Currently, in 2020, they have over 140,000 characters, different symbols represented in Unicode, and they cover about 150 languages. It's not just living languages that are used every day around the world that have their symbols and characters represented in Unicode. There are also characters that are no longer used except in historical documents, or that are special characters, symbols for technical things and so on. And of course, there's also, these days, a large range of emoji characters, which I'm sure you're all familiar with. So let's look at a couple. The smiley face has a code in hexadecimal of 1F600. Now I write it in hexadecimal because to read out all the ones and zeros there would take a while, but let me try. So the first one is 1, 1, 1, 1, 1, 0, 1, 1, 0, 0, 0, 0, 0, 0, 0. And I was able to read that off because if you remember in the lecture on binary, I showed how easy it was to convert from hexadecimal to binary and back again. As another example, there's another emoji which is very current, and that is the one that has a smiley face, but it has a face mask on. And this has the code 1F637 in hexadecimal. Now, you've got to note that the characters here I'm talking about, these symbols, are based on what they call the grapheme. In other words, the root image of the character, and you shouldn't confuse that with the variations due to the different fonts. So, for example, I've got the letter A here twice, capital A, but they're both the same Unicode character. You have to have other information if you want to represent the font. Now, I thought I'd show you some other characters that you can get if you use some of the Google products like Google Docs and Google Slides. I'll show you in a moment how you can get any of the Unicode characters displayed in those products. And once you know the code, you can then embed them in documents of all sorts. Microsoft Word has the ability to do something like this as well. This is Google Slides, so I'm going to add some extra characters in here. So I've highlighted this box. Now up here I go to Insert and choose a special character. And what it does is it pops up this this box, and it lets me choose different sets of characters. And notice here in this symbol set there are a large number of symbols I could choose. That was arrows, but here we are, we've got Braille, control pictures, I don't know what that is. We've got currency. Here we go. Lots of currency symbols, so as well as the cent, the pound sign, and so on, many other symbols for currencies. Come to the emoticons in a minute. Game pieces, geometric shapes, math symbols, and so on. Music, technical, all kinds of things can be represented here. If we move from the symbol, we can go to emojis. Here we've got all our emojis, and there's a whole, many sets of those that can be represented, and so on. Here, let me just pick a random one, a heart here. If I choose the heart, it might be a little difficult to see, but it shows, now I've highlighted it, the yellow heart, and it has the Unicode. It says U plus 1F498. That's the Unicode code for that yellow heart. Let's see what else there is. Got many other scripts. Here we go with Chinese scripts and so on. And so it's very easy once you've chosen which particular set, which category you want. You can choose, let's go to other European scripts. Over here we've got a language, so we go to Greek, and here we have all the Greek letters. We go to, let's say, Middle Eastern scripts, we'll find Arabic and many others, Hebrew, and so on. So let's just try Aleph here. Right, so you can see that the code for the Hebrew letter Aleph is 0500. So it's very easy then to select one of these. And if let's put a few Alephs in. And now when I get out of that, I'll see what I've been typing. You can see here I put the heart, and then I put the Aleph character, and they've just appeared here. And what's embedded in the document is the actual Unicode value. Now, you might say, well, wow, 4 bytes per character. That's going to be a huge waste of space if all I'm writing is documents in, say, the English language, which has a much limited character set. Remember, the ASCII character codes could be fitted into 128 different values, and so 4 bytes is an awful lot. It would multiply the size of all your documents by 4. So this problem was recognized right at the beginning of the development of Unicode, and people came up with ways of compressing the Unicode character codes into something smaller. And in many cases you can squeeze it down to a single byte because you use variable length coding. And the most popular encoding here is something called UTF-8, or which stands for Unicode Transformation Format Number 8. Now what we're doing here is actually encoding the encoding. Unicode is a code for characters, and UTF-8 is a code for Unicode. Now, the nice thing here, the trick they've done with UTF-8 is they made all the ASCII characters the same value as they've always been. So if you have a character which has a 0 as its first bit in the byte, and then it says, this is one of the ASCII character codes, and it uses the remaining 7 bits for the ASCII code. However, values larger than 127, in other words, the first bit is 1, would indicate a character which is not in the ASCII code and might be more than 1 byte. And there are ways of encoding 2 bytes, 3 bytes, and up to full 4 bytes, which give you the full Unicode character set. Unicode is very popular, and UTF-8 in particular is very popular, and it's used by more than 90% of all web pages. Here's another example. So the letter capital A, remember I showed you what the value was for ASCII. In Unicode, it has basically the same value, but here I've written as a hexadecimal number, a 32-bit hexadecimal number, and it's simply the number 41. If we were to encode this in UTF, then it becomes still 41, except we drop those leading zeros, which is the same as the ASCII code. Most programming languages now have support for Unicode, and for example, the language you will use in this course, Python, uses Unicode for all its character strings. And sometimes it's difficult to enter the Unicode characters, and you might have special support on your keyboard or a different keyboard. You might have a keyboard which is designed for French or other languages that include the graphic symbols on the keys themselves, or you might just have to remember it and have a little card that tells you where the different symbols are. Alternatively, there are ways of typing in the exact hex value for the character if you just want a one-off or a couple of Unicode characters. So We've now seen that almost any character, the symbol, can be represented with a string of bits, and the most widely used standard for this is Unicode.